Good job.
Hey everybody, it's Eric Hayden here with the Weather Service. It's just about 10:29. We still have a little ways to get going, or another minute or so, but I'm joined by Mike, Belle, Sarah, and Charlie. We're all scientists, so we're going to be doing your presentation today. I'll kick things off here in about a minute or so. We're going to go over how you can ask questions throughout. You'll have an opportunity to do that. We'll take those questions and answers at the end, and we're going to try to make it as interactive as possible. We're going to give you the opportunity to answer some of our questions that we have for you. So if you hear me, if you see the other meteorologists and scientists on the screen, and you should see the presentation Weather Basics, you're all good to go. So just kind of sit back and we'll get started here. I see that it's 10:30, so we'll get started now. So again, this is Weather Basics. We're going to talk a lot about meteorology. We're going to talk about climate. We're going to talk about sea level rise. The goal of the presentation is about 45 or 50 minutes, and then we'll turn it over to you to answer some of your questions. My name is Eric Hayden. I'm a meteorologist with the Weather Service. My other coworkers, Belle Melendez, Charles Bowen, and Michael Lee, they are also with the Weather Service, but with our current situation, we're all doing this from home. And we have a special guest with us today, Sarah Stiegler. She's done this with us before with our Google Hangouts. She's done sea level rise, and she's going to talk about that at the end of the presentation today. So a lot of different scientists on the talk today. As far as asking questions go, through the webinar, if you just raise your hand, you're going to use that feature later. We're going to ask you a question. I'm going to ask you to raise your hand, and then we'll call on you. The other feature you can do is the actual ask question feature. That will go directly to me. Nobody else sees the question. And then at the end of today's class, we'll go around, we'll ask the question out loud, and either myself or one of the other scientists we have on will go ahead and answer it. So we're going to get started. I'm going to switch things over to Belle. She's going to talk a little bit about what meteorologists do. She's going to talk about who we are and some of the different things we do in the Weather Service itself. So Belle, I'm going to hand it over to you. And Belle's going to get started with what meteorologists do.
All right. Well, good morning, everyone. As Eric ended mentioning, my name is Belle Melendez. I'm a meteorologist at the National Weather Service located in Newport. So to continue with our presentations, what do meteorologists do? When I tell people I'm a meteorologist, automatically people think that I am a TV meteorologist. I'm always on TV. Well, matter of fact, there's meteorologists in every sector. Think about it right here, as you can see in the graphic in the middle. We have meteorologists in the military. We have meteorologists in the academia. Right here, he's taking a sample, a snow sample. And then, of course, we have a meteorologist, I call it in the research department, as you can see here in the bottom picture with a satellite, which is, I call it Ohio University, which I'm not promoting them, but just kind of an example showing how they do actually, how call it research for the university there, actually tornado chasing. While we at the National Weather Service, we actually do a lot of operational meteorology. We are the ones that issue the advisories, watches, and warnings. We're the ones that we have to tease you every time when the warning on the cell phones, that funny noise. That's actually what we do. While the people at the TV, as you can see in the bottom, with the green screen, here they're actually using a green screen. I know it's kind of funny looking, but yes, that's what meteorologists, TV meteorologists actually use. They use the green screen, and as you can see in that photo, you do see a TV on the other side, and what's actually displaying the graphics. But as I stated, there's meteorologists in every corner, in every field that you could think of. Okay, so we have National Weather Services offices located throughout our country. As you can see, these dots all around, these are representing a National Weather Service office at each of these points, and they are responsible for a certain area of coverage that they're supposed to be responsible for. So as you can see here, from west to east, we have offices throughout. But we also have to think about, we do have offices located up in Alaska region, okay, which you can see right here where I'm circling around. Then, of course, we have an office in Hawaii. But of course, we cannot forget the offices way out in the Pacific Ocean, which is Guam and American Samoa. And then down in the Caribbean, yes, we do have an office down in the Caribbean, which is San Juan, Puerto Rico, down here, which is nice. I can get the tropical weather as well. So to move on, this is our area. I know there's our people who are outside our region at this moment in this in this webinar, but I just want to indicate that this is the area that we're actually responsible for. We are responsible for Martin County down to Duplin County and then eastward. We are responsible basically from Duck all the way down to Surf City out to 20 nautical miles. And that is including the Aramau Sound, Alligator River, the Neuse River, Pamlico River, and of course, the Pamlico Sound. And then the other parts of offices, we have the Raleigh office that is out to the west of us. To the north, we have Wakefield. And then of course, down here is actually Wilmington office. These are the offices that cover North Carolina. Well, the National Weather Service office, we never close. We're always open 24 hours a day, 7 days a week, and 365 days. Well, except for this year, we have leap year, which is 366 days. But this is a prime example right here, as you see in these pictures, this is during Hurricane Florence. You can see in the upper left-hand corner, that's us bunkering in. This is the whole staff living in this office during this time frame. You can see in each office, we're putting beds, air mattresses anywhere. And then of course, our office is actually built to withstand hurricane situation. Of course, we do have the hurricane shutters. As I stated before, we're 24/7 out of the week. Okay, normally on a given day, we have about 2 to 3 forecasters per shift. We do have different shifts. We have the midnight shift, the daytime shift, and the evening shift. And of course, the management team, well, they have it a little bit easy. They have it from 8 o'clock to 5 o'clock. But hey, I can't give them too much gripe. They actually have to work shifts as well. So if I take off or one of my other fellow coworkers take off, they are actually covering for us as well. So here's our website. If you go to weather.gov/Newports, this will bring you directly to our website. Also, just recently they actually added weather.gov/Morehead City. So you can type in either Newport or Morehead City, and it will direct you directly to our website. So here in our website, this is where you could get all the weather information from the past, current, and past weather and current forecast. You can actually bookmark this website, please, and you can find so much information. As you can see, we have tropical, local radar, satellite, whatever you are thinking or looking for, you can find it here. So here's an example of our 7-day forecast. Our 7-day forecast basically consists of cloud cover, high or low temperatures, wind, and then the chance of precipitation. So as you can see here, today's forecast, which is not technically today, but if you look, it says today mostly cloudy with highs in the near 54 degrees. Light winds from the northwest. So that's just an example right there. Also, you have the graphics. There's another spot that you can actually look for the forecast if you're more like to see things visually. It's called the Graphical Forecast. And here, it basically you could change parts under this down menu right here where I'm pointing at, and you can put a maximum temperature for the day, minimum temperature, amount of cloud cover, anything that you're looking for. You can actually select what date that you're looking for. And it gives you a really easy view of seeing the overall aspect of the forecast. I know we have a lot of mariners and where we are responsible for. So here, you can see an example of the marine forecast. Obviously saying rest of today, north winds around 10 knots. But as I mentioned before, we are responsible from basically Duck or Kirkduck Beach lighthouse light down to Surf City, out to 20 nautical miles, including the local sounds and rivers. And as I mentioned before about the forecast, it includes the winds, wave height, precipitation chances, and obstruction to visibility, because there are times that we do tend to get sea fog, especially during the fall and springtime. The forecast is normally updated about 3 times, sorry, correct myself, every 3 hours. Also, people don't really think about it, but we actually do the aviation forecast for our regional airports around here. For example, Newbern Airport, which is coastal Carolinas, I call it the Jacksonville Airport, which is located in Richlands, and then of course Greenville. So those are some of the airports that we are actually responsible for providing the forecast. And within the forecast, we provide the wind speed and wind direction, the height of the cloud, visibility, and tell them if there's any threat of thunderstorms. And of course, really important for airports, it's wind shear. And what I mean by wind shear is really basically really strong winds continuously, kind of a little bit different from wind gusts, but that actually is really important for the airports. And the forecast is actually done every 6 hours and updated as needed. So as you can see, we do the forecast at 7 a.m. And 7 p.m. Eastern Standard Time. And then during the summertime, when we are in daylight time, we do it at, I call it, my apologies, sorry, at 1 a.m. and 1 p.m. My apologies, is Standard Time. And lastly for me is that fire weather forecast. A lot of people don't really think much about the fire weather forecast, but we do have a graphic for this. But when it comes down to fire weather forecast, we are actually providing forecasts for our U.S. forestry departments, North Carolina forestry, and every other state. We provide forecasts. And this, we provide the wind speed and wind direction, maximum and minimum humidity, mixing height, transportation winds, and smoke dispersion. And this actually helps them to, if there is a fire, they know what these weather conditions are occurring, because they know what to plan and how to battle an actual wildfire. They know where to put people for them to be safe. So weather information is really important for the IMETs, and that's what I mean by IMETs are the people who go out to the field and along with the firemen, I call it, to battle the fire. So this information is really important for that. This forecast is actually done twice daily, and we do localized spot, and spot forecasts are, and what I mean by that is a specific location, and we provide that the specific information for weather right at that specific area that they're looking for. So now I will pass you on to Eric Heaton, who will talk more about weather instruments now.
All right, Belle, thank you very much for doing that. So Belle really laid the groundwork for who we are as a weather service, and I thought she did a good job. That we have a lot of folks joining us from all over the country. Weather.gov, if you just go to weather.gov, you can click on anywhere in the United States and you'll get your local forecast. So Belle laid the groundwork. I'm going to talk a little bit about instruments, seasons. Then Charlie's going to talk about pressure and fronts, a lot of things you need to know, especially for your 5th grade standards. And then toward the end, Mike's going to talk about general preparedness and hurricanes, and Sarah is going to talk about sea level rise. So weather instruments, to get those forecasts that Belle mentioned, you need to measure the atmosphere. And we use things like an anemometer to measure wind speed, a rain gauge for precipitation, or a thermometer to measure the temperature. And we do this at the ground. We need to know exactly what's happening now before we forecast the future. If we don't know what's happening now, it's really hard to make a prediction of what it's going to be like down the road. This is our office. Usually when we do Hangouts or a virtual presentation like this, we give you a virtual tour, but we're all taking part in our social distancing. So at the office, we just have a few forecasters, and most of us are at home. If the weather gets bad, then we'll have more staffing. But this is what our office looks like right now. For the teachers that are on the call right now, when we return to normal, just like we will eventually, we do hangouts. So you're welcome to take a virtual tour of our office, and we do also do office tours. Obviously not right now, down the road, but we're welcome for you to stop on by our office. One of the neatest things you can see at our office is actually the weather balloon launch that we do. We do these in the evening. Belle mentioned the aviation forecast. It's usually very similar to that timing. I mentioned that we measure the atmosphere, the temperature, the wind speed at the ground. The weather balloon goes up into the atmosphere. It can get as high as 110,000 feet before it pops. And as it goes up, it samples the atmosphere. How warm is it? Is it moist? What's the wind direction? That's crucial information for our forecast, but also not only the day-to-day forecast, but big things like hurricanes, will actually do it 4 times a day instead of just twice a day. At the very end, we're going to do a follow-up with you with a certificate. Mike is awesome with graphics. He made a certificate for this. Included in that email is going to be links for this information, and I'll link you to our YouTube page. We have a whole video, in fact, multiple videos on the actual launch of the weather balloon, so you'll certainly want to check that out. Another tool we use for forecasting is the Doppler radar. On the right, it looks like a giant soccer ball. That's the protection of the radar. The lower left is a gentleman that's about 6 feet tall, and that gives you some perception for how big that satellite is. It's actually about 25 feet across. That rotates around, and it shows us things in the atmosphere. Is it raining? Is it snowing? Do we have hailstones? Is there any rotation? We don't actually see tornadoes, but it will show us where the rotation is in the atmosphere. And from that, we can issue warnings if necessary. So we started small, temperatures in your backyard. Then we got a little bit bigger. Weather balloons measure the atmosphere above us. Radars can see hundreds of miles away. And then weather satellites are 22,000 miles up in the sky. They're looking down at us. And this is how we see big weather features even before they get here. If you live locally, think back to Florence. We knew about Florence weeks before it happened. The reason because of that are weather satellites. They can see things all over the world. Where it's cloudy on this map, you see white. Where there's no white, that's a lack of clouds and it's sunny skies. So we can see large storms where it's raining, or at least where it might be cloudy, and where it's sunny out. So we laid the groundwork a little bit with instruments and what we use as a meteorologist. Now I'm going to switch gears and we're going to talk about seasons and why weather happens. And that's kind of a real good transition to Charlie. He's going to talk more about pressure, high and low pressure, and kind of how it all comes together. Well, before we talk about where it comes together, we have to start. And we start with the sun. The sun heats the atmosphere differently depending on where you live. What hemisphere you're in, if you're near the equator or you're farther away. So we'll start first with where you live. The sun heats the atmosphere, but it really heats the ground itself. In turn, the graphic on the bottom, that ground actually warms the air just above it. And it depends on where you live. If you live higher up on a mountain, notice on the far left, it gets cooler as you go up in the atmosphere. So depending on your elevation, the earth heats up differently. Some of us down here on the Crystal Coast, if you live here locally, we're really fortunate we live by the Atlantic Ocean. If you're closer to the water, sometimes you're cooler. If you live farther away from the water, sometimes you're warmer or hotter. It just depends where you live on the earth. So the whole point of this slide is not everybody heats up differently. The weather is different all over the world, and part of that is because the sun heats the atmosphere and the land masses differently depending on elevation or proximity to water. I'm going to throw one more thing at you. The earth also heats up differently based on the season. So we're going to go over the 4 seasons, and then we're going to turn it over to you for a few questions to make sure you're getting everything. So we just had this. We had the vernal equinox. That's the first day of spring. The autumnal and vernal equinoxes are the first day of spring and the first day of fall. Autumnal would be fall. They usually occur about the 3rd week of March or the 3rd week of September. During that time, the earth is not tilted toward or away from the sun. It's actually equal, and that's why the word equinox is from the Latin word equal day and equal night. When that happens, the sun's strongest rays, most direct rays, it would be like I'm shining a flashlight, are most direct over the equator. And as you get farther away from the equator, the rays are not as direct. But the important thing to remember is the Earth is not tilted toward or away from the sun. Gradually, and this is going to happen to us here over the next couple of weeks and months, gradually as we get toward the summer solstice, the Earth slowly tilts toward the sun in the northern hemisphere. So as that happens, notice that sun angle of 90 degrees, the most direct rays, they're actually now focused on the Tropic of Cancer. That actually touches the southern tip of Florida. So the most direct rays occur on the first day of summer here in the northern hemisphere. This is usually about the third week of June. This is when we have the strongest rays up here. The important thing to remember for this is the Earth is tilted toward the sun in the northern hemisphere. We're summertime. In the southern hemisphere, it's opposite. So whenever we're the first day of summer here in the southern hemisphere, South America, Australia, they are the first day of winter. So it's always opposite when you're comparing hemispheres. We'll go forward one more. Gradually, the Earth tilts toward the sun and then eventually away from the sun here in the northern hemisphere. When that happens, it's called the first day of winter or the winter solstice. And notice now that 90 degrees, again, that's that flashlight, the strongest rays are now directed on the Tropic of Capricorn. So that would be the first day of winter for us. And that would be the first day of summer in the southern hemisphere. I'm emphasizing that point because I have a feeling we might be asking you that here coming up shortly. All right, 1 or 2 slides on pressure. We're going to do some questions, and then Charlie, get set. We'll turn it over to you here pretty soon. So because the Earth heats up differently, mountains, land, elevation, depending on where you live, or what hemisphere you are and how close or how far you are from the equator, the Earth does not heat up the same. And because of that, that causes an uneven pressure distribution. All those blue H's on the map are high pressure, and Charlie's going to talk more about what kind of weather you can expect with that. All the areas of lower pressure are noted with the red L, and that's the low pressure. And again, he's going to tell you a little bit about what kind of weather we can expect with that. Because of the difference in pressure, things always flow from high to low, and that is called wind. So again, take a few steps back. Starts with the sun. The Earth heats up differently depending on where you live. Not only, and it also heats up differently depending on the season. Because of that difference, we get wind. So we kind of tied everything together right there. All right, enough of us talking. We're going to turn it over to you here in a second. So what I want you to do is look at this question. If you think you know the answer to it, raise your hand. I'm going to call on you. If you have a microphone, you can answer that way. So only raise your hand if you have a microphone. If you have a mobile device, a lot of things have microphones now. We're going to give this a try. So because of the Earth's 23.5 degree tilt, what do we get? Do we get day and night? Do we get gravity? Do we get winter, spring, summer, and fall, the seasons? Or do we get the lunar cycle? So I'm going to go over here and look at the audience, and let's see here. Again, if you've got a microphone, raise your hand if you think you know the answer, and I will call on you and I will mute your line. So let's see. So any hands up? Do we see any brave souls? If not, you can answer on your own. All right. So I see Will Vaden has raised his hand. So Will, I'm going to unmute your mic. All right, Will, are you there with us?
Yes.
All right, Will, what do you think it is? Do you think it's 1, 2, 3, or 4?
3.
Will, exactly right. Very, very, very good job, Will. So Will answered 3. If you're answering from home, he is 100% correct. It is the seasons. Will, thank you very much. Very, very good. All right, one more, and then I'll turn it over to you, Charlie. When it is summer in the northern hemisphere, what season is it in the southern hemisphere? So it's summer where we live. What season would it be down in the southern hemisphere, places like Australia? Would it be the same, summer? Would it be opposite, winter? Would it be fall or spring? So let's see here. Let's see if we got anybody. All right, so we've got Brittany Kearns. So Brittany, I'm going to unmute your mic. Brittany, are you with us? All right, Brittany Kearns, are you with us? She might be still messing with her
Can you
mic.
hear us now?
I can. Perfect.
Hey, got Rebecca and Anastasia.
I think it would be winter. Winter.
You are 100% right. That's fantastic. Very, very good. Very good. So that is 100% right. It's always opposite. So think opposites. Whatever we are where we live, because we live in the northern hemisphere, it's going to be the opposite in the southern hemisphere. So now I'm going to turn things over to Charlie. Charlie's going to talk a little bit about pressure. He's going to talk about fronts, and it looks like he's going to get down to the water cycle. So give me a second, Charlie, and I will send it over to you. All right, so Charlie's up next. He's going to talk about pressure, fronts, and the water cycle. It's all you, Charlie.
All right, hi everybody out there in Internet Wonderland. Talking about high pressure systems, again, they're noted by those blue H's on the weather map. H stands for high pressure, which brings happy weather. So traditionally, high pressure systems lead to, we've got clear skies, calm conditions related to the wind, drier weather, high temperatures during the day and low temperatures during the night. If you look at this graphic over here, you see that cold air is sinking from aloft up in the upper atmosphere, and when it gets down to the surface, that air's got to go somewhere. So you see the air blowing out away from this high pressure out at the surface. If you take a look at the low pressure system, it's the exact opposite. So low pressure stands, or the red L on the weather map stands for low pressure, which brings lousy weather. Traditionally, low pressure systems at the surface are associated with cloudy skies. You've got windier conditions, wet weather, and then which is eventually followed by colder weather. So we see all the wind blowing in towards the low pressure symbol, the center of that low pressure system. And all that air blowing in towards it has to go somewhere. It runs into each other and then it starts rising up towards the atmosphere. And that's how you get your cloudy conditions and your wet weather as that warm air starts to rise and move up through the atmosphere. Looking at warm and cold fronts now, this fronts are the separation areas between two different types of air masses. So a cold front up here on the top is, as the graphic moves along, you see the cold air moving into an environment of warmer air. So this warm air ahead of the cold front runs into this wedge of cold air and starts to rise, and that's how you get your showers and thunderstorms. So this cold air is displacing or moving this warm air out of the way, and that warm air has got to go somewhere, and it rises up. It's less dense than the cold air below it, so it starts rising up, and that's how you get your showers and thunderstorms. Traditionally, cold fronts move a little faster than warm fronts. Warm fronts are a little more slow moving. Over here, you see the warm front. So you see the warm air is overtaking the cold air that's already in place. So the cold front is cold air is moving into warm air, and the warm front is warm air moving into cold air. This one, you can still get clouds and rain, but it's not going to be as severe. It's not going to be as heavy a rain with the cold fronts. It's going to be a different type of rain, different type of clouds. But again, this is warm air is displacing, is moving away the cold air in the environment. Typically on a weather map, you see here's the high pressure, and that is always going to be located behind a cold front. So the high pressure is the big H, the big blue H, and that's going to be associated with the cold air behind the cold front. On weather maps, the cold front is indicated with a blue line with the blue triangles along it, and that represents the separation of the two different air masses, the cold, dense air over here behind the cold front, and the warm air associated ahead of the cold front. Up here, you see the low pressure system with the low indicated with the red L, and the fronts are actually connected to that. So this one, you've got the cold front with the blue line and blue triangles. This is almost, not always, but most of the time it's going to be oriented like this north-south orientation. And then the warm front is going to usually run east to west. And this warm front is indicated with this red line with the blue circles. I'm sorry, with the red circles. Right, now we're going to talk about the jet stream. And the jet stream is a narrow band of very strong winds aloft. So we're talking pretty high up in the atmosphere, up where the commercial airplanes fly. Rivers of air, and it's the strongest winds within the jet stream are going to be on the very center of it. So on the outside of the beginning of the jet stream, you could have winds as high as 80 miles an hour, and that's actually hurricane force winds. But once you get into the actual jet core of the jet stream, you can get winds as fast as 140 miles an hour and sometimes even faster. There's multiple types of jet streams. You've got the polar jet, which is up here in the north, which separates, you got your polar air mass and your continental air masses, little mid-latitude air masses. And the separation between the cold and warm and the elevation and the pressure changes are what give us those wind changes and give us those jet streams. A little further south, we've got the subtropical jet. That's not as strong as the polar jet, but it is rather influential in the weather, and that's located a little further south, a little closer towards the equator. There's also a polar jet and a subtropical jet in the southern hemisphere. And like I said, they follow boundaries between the hot and the cold air. The location of the jet and how strong the jet is, how the jet is oriented, is very important on forecasting weather. We can look at how the jet is oriented, how far south it is, how strong it is, and we can get an idea on where severe weather may or may not happen. Ocean currents are essentially they're like a jet stream, except we're talking about the ocean now. So along the east coast of the continents in both the northern and southern hemisphere, we've got currents that are moving away from the equator. So we can see this over here in Asia. We got the east coast of Australia, east coast of the United States, and the east coast of South America. Because they are moving away from the equator, that's where the sun is going to heat the most. So that's the water is going to be the warmest there. So these are warm water currents moving away from the equator. Then traditionally on the west side of continents, you've got currents that move towards the equator. So over here on the west coast of California, you got over here in the South America, South Africa, Western Europe, and then on the western coast of Australia. So they're moving away from the poles up here, which is traditionally very, very cold. You don't have nearly as much heating. So this is cold water currents that are returning towards the equator that bring cold water from the north and bring it further south to the equator. The Gulf Stream here on the east coast of the United States is one of the strongest currents there is. It can get as fast as 3 miles an hour at times. That keeps areas like Norway and the British Isles, up here in northern Atlantic, that can keep temperatures in those locations 18 degrees warmer than areas that might be inland or away from the Gulf Stream. So like I was saying, the currents on the west coast are going to be coming from the poles. They're going to flow towards the equator, and on the east coast of continents, they're going to be moving away from the equator. So the source, the equator, warm, moving away. The source, poleward waters, cool, moving towards the equator. So water is the only substance on Earth that occurs naturally in all 3 states of physical matter. We've got solid water, as in ice. You got the polar ice caps, icebergs, glaciers. Liquid water in the rivers, the ocean, and then gas, water vapor in the atmosphere, which is very huge for meteorology and forecasting. Here we take a look at the water cycle, just starting with meteorology because I'm a meteorologist and that's what I'm most interested in. We've got clouds, which is made up of water vapor. Then that forms precipitation, which falls down to the earth. And as it falls down to once it reaches the surface, you've got surface runoff, which can lead to ponds, groundwater, aquifers underneath the water. And then the next step in the water cycle would be evaporation, which could come from oceans, lakes, streams, or little ponds. And then as that water lifts up, then it condenses again, and that forms the clouds, which leads to the precipitation. Another huge part of the water cycle is vegetation. You get transpiration from plants, trees, and the organisms that live in them themselves. All right, so leading to a question for all of you guys. The most common type of weather associated with high pressure is blank. Is it 1, cloudy skies, 2, gusty winds, 3, sunny skies, or 4, thunderstorms?
All right, so we're going to look for raised hands here. I'll take care of that part, Charlie. So Charlie asked the most common type of weather. Let's see here. And unraise your hand if you answered before, otherwise I will be calling on you again. So let's see. All right, good. We got some different people here. So we've got a Melissa Glenn on the phone or on the line. So Melissa, I'm going to unmute your line. And oh, yep. Can you? Are you with us, Melissa?
Hello.
Is this William?
Yeah.
All right, William. What do you think it is? What do you think the most common type of weather is?
I think it's sunny skies.
I think you're right. Go ahead, one slide, Charlie. Really good. All right, William, thank you very much. So again, if you all have a microphone, you can answer those questions. Very good, William.
Right. And the last question I have for you, the most vigorous weather, for instance, thunderstorms, occur with what kind of front? Is it 1, warm front, 2, cold front, 3, occluded front, or 4, none of the above?
All right, same thing. Unraise your hand if you're not sure about this one. This is a hard one. Charlie mentioned a little bit about how the cold air was really dense with some things, so that's a little bit of a hint. But let's see here. This one is probably the trickiest one. Will, you already answered. Let's see if we can get somebody else. Let's see. All right. So we've got a Jonathan Mumford. So Jonathan, I'm going to unmute your mic. And are you with us, Jonathan?
Yes.
All right, Jonathan, this is a tough one, probably the toughest one we've had so far. The most vigorous type of weather is with what front? What do you think it might be?
I think it's 2, cold front.
Wow, awesome. Very, very good, Jonathan. That's outstanding. That is not the easiest one there. And you can always use your process of elimination. Charlie didn't talk about occluded front, so you can kind of scratch that one off. That was very, very good. All right, Charlie, I think you're done, aren't you?
Yes, sir. I'm going to hand it off to Mike, and he's going to go over some severe weather stuff and how to be prepared for them.
All right, Mike, I'm making you the presenter. So Mike is, as Charlie says, going to wrap things up here with preparedness and hurricanes, but not wrap things up. We're tying everything together. We got to talk about weather first, because at the end, he's going to transition over to Sarah and talk about climate and sea level rise. So you got to start small first before we can expand. So Mike, take it away.
There we go. All right, can everyone hear me? All right.
Yes.
Cool, fantastic. So we talked about low pressure systems, high pressure systems, cold fronts, warm fronts, all those things, everything that makes the weather. But we're going to talk about now how the weather impacts us, and also the different weather risks that we have to be concerned about right here in Eastern North Carolina. So the first thing I want to talk about is rip currents. Not a lot of people think that rip currents is going to be the most dangerous type of weather event that we have, and it's kind of a weather/ocean event. But in all honesty, in Eastern North Carolina, rip currents is the #1 killer of all weather events for us. So rip currents impact us more than hurricanes, impact us more than tornadoes. This is going to be the most dangerous one, and because at first it doesn't look so bad, and that's why it's so dangerous, because sometimes it's very deceiving. If you guys have heard about rip currents before, you know that rip currents are powerful currents of water that move away from the shore. And what happens here is that, one second, move a couple of things around. So what happens here is that as we have waves that crash along the shore, so the waves come in and then they go out. And what happens occasionally is that those waves will, as they're coming out, will get a little bit stronger. And we'll see this very narrow area of current that's just pulling folks closer out to sea. So sometimes the waves come in and sometimes they come out really, really strong. And what will happen is those rip currents will pull people away from the shore, and you'll be taken about a couple yards, maybe a couple of dozen yards out into the ocean. And it's really important to know that if you get caught in a rip current like that, the first thing you want to do is you want to make sure that you relax. That's the biggest thing to do right there. Relax. You're not in, it's not going to pull you under. The rip current's not going to pull you under. It's not going to cause you to, go underneath or anything like that. All it's doing is pulling you out. First thing to do is relax. What happens a lot is that some people try to swim back against the current, and that's a bad idea. So you want to make sure you don't swim against the current. You want to make sure, number one, that you relax. And the next thing you want to do is you want to make sure that you don't swim against the current. What you actually want to do is you want to swim parallel to the shore. So swim out again, parallel to the shore. You can go left, you can go right. Once you get out of the current, because this is going to be a very narrow channel, just swim out of the current and then back in towards the shore. And if you can't escape the current, all you have to do is float, wave, and yell for help if you need assistance. So really quickly, again, what should we remember? If you're caught in a rip current, you can float, wave, and yell for help, or you can swim parallel to the shore and then back in towards land. All right? The next thing I want to talk to you about is tornado and high wind safety. Anytime there's a tornado, if there's a really bad thunderstorm, things can get kind of dangerous outside. We always tell people to take shelter. Think about it now that you're at home. Think about it right now. Where is the safest place for you to take shelter at home? When there's a tornado, the best place to take shelter is underground in a basement or a safe room if you have it, or a storm shelter of some sort. If you don't have a basement, and a lot of folks don't, but if you don't have a basement, the next best thing to do is find an interior room or stairwell or closet or bathroom that is inside the middle of your house. There's no windows and there are no walls next to the outside of your home. Again, avoid windows, try to avoid doors and outside walls. Think about that one location that you have inside your house that's going to be safest in case you run into tornadoes or thunderstorms. We have severe weather season coming up soon. Eastern North Carolina, we do see a couple of tornadoes every time around this time every year. So we're not all that unfamiliar from tornadoes. Again, if there's no shelter on the ground, go to a safe room that is small, it has no windows, and has no walls on the outside. Another thing that comes by with thunderstorms is lightning. If you've ever been outside and you ever heard thunder while playing outside, the big question is, what do? We always tell folks, and especially the kids like your age, when thunder roars, go indoors. Thunderstorms can produce a lot of lightning, and they can strike up to 10 miles away. And if you hear the thunder, guess what? You have to go inside. So even if you don't see the rain, you could still be in harm's way. Always stop all outdoor activities and seek shelter if you hear thunder, because that means a thunderstorm's close by and it can hit you with lightning. What you want to do also is, once you're inside, you have to wait 30 minutes until the storm's over or until the last rumble of thunder is heard. So the last time you hear the rumble of thunder, wait 30 minutes, and once 30 minutes passes, then you're safe. The next big thing that we're pretty familiar with here in Eastern North Carolina are hurricanes. They are really the greatest storm on Earth. And around the world, they're known as different things. Here in the Atlantic Ocean, they're known as hurricanes. Out in the Pacific, they are known as hurricanes as well. But once we start getting to the Western Pacific, they're known as typhoons. Out towards places like Japan and South Korea, out towards the Indian Ocean, they're just known as tropical cyclones. And then down in Australia, our friends down under, they call them willy willies. So what forms hurricanes? Charlie talked about that low pressure system, and that's a very similar thing. We have low pressure systems on land, but then we also have them out towards the ocean. And what happens during hurricane season, which begins in June 1st, is that these low pressure systems that move out into the ocean, they have a lot more energy to work with. There are a lot of warm ocean waters. They're fueled by any ocean waters that have more than 80 degrees Fahrenheit. And that's important to know, because you can't get hurricanes if the waters are colder than 80 degrees Fahrenheit. They don't last very long. They'll start weakening with temperatures less than 80 degrees Fahrenheit. But if it's really warm, 80 degrees, 90 degrees, yeah, we have a lot of fuel. What happens is with that low pressure system, that warm, moist air gathers around the center of that low pressure system and moves up and builds these big clouds. And that's what starts creating a hurricane. On top of hurricanes, they can provide a lot of flooding as well. And this is probably another really dangerous thing in Eastern North Carolina is flooding. Anytime you see flooded waters, we tell you, hey, don't go into flooded waters. We tell folks, turn around, don't drown. It only takes 6 inches of water to knock your parents off their feet. So that's an adult. It takes a lot less for kids. Never walk into flood waters. It could be flooded roadways. It could be flooded sidewalks. It could be a river as well. You don't want to go inside the waters. Those are very dangerous. The last thing I want to touch upon is weather and climate. So a lot of folks, you know, they hear about weather, the forecast for the weather, but they also hear things about climate as well. And I just want to touch upon really quick difference between weather and climate. Weather happens at a particular place, time and place, and climate is a regional and long-term type of thing. One analogy is that the weather is kind of like the news, what's happening in the news today, what's happening you know, in the next couple of hours, or the climate is your history. Another good analogy that I like to explain to folks is that the weather is like your mood for today. Some days you're having a good day, some days you're having a bad day. Some days you're really, you know, giggly and hyper, and some days you're really sleepy. So the weather changes from day to day, sometimes hour to hour, whereas the climate is kind of like your personality. That's who you are. That's who you've been. Let's say that you're a pretty happy person, and people know you. Hey, you're a happy person, and you know your personality is overall positive, and that's what your climate is. If you're having a bad day though, and that happens once in a while, that'd be your weather. That's a bad weather day, right? And so that's the difference between weather and climate. So I'm going to go ahead and hand it over now to Eric, who will introduce you to Sarah.
All right, Sarah, I just shared the screen with you. So Sarah Stiegler is with the Sea Grant, and she's done a lot with us recently. Sarah's a scientist. She's a marine scientist, so she specializes in things like sea level rise. And we're so fortunate to have somebody like Sarah present with us because we're meteorologists, and we're focused a lot on the day-to-day weather that Mike talked about. We're not as focused on the long-term impacts of our changing climate. So Sarah's going to talk a little bit more about that. Sarah, it's all yours.
All right. Can you hear me, Eric?
We can, and the screen looks perfect.
Okay, great. Well, first, I'm Sarah Stiegler, and I work with North Carolina Sea Grant. And I want to say a huge thanks to Eric and everybody at the Morehead City Weather Service office. They are really great to work with, and they do a lot of really important work for us. They help us predict the weather, and like they said, their office runs 24/7. So I just want to say a huge thank you to them for all the work they do and for inviting me today to talk to you guys. So I'm really excited to share some of the things that I do in my job, and I'm really glad that we're learning about weather and climate. And I'm going to talk about it again because it's so important in what I do in my job. So like you just heard, weather is what's happening day to day. So today we can talk about the weather. What does it look like outside your window? Now, if I look outside my window right now, it's sunny. In fact, my dog is sitting out on the porch, laying out in the sun because he loves weather that's sunny and warm. Sometimes in the wintertime, it's really cold and he wants to come inside. So that's what weather is. What's happening outside your window right now. Now, when we talk about climate, we're talking about weather that happens over many years, so over 50 to 100 years or even more. And that's really, really important to understand the difference between those two. So climate, you can think about, there's different parts of the world with different climates. So for example, if you think about a desert, and you can look at that map on the screen, a desert is usually very hot and dry. And so you can think about over 50 to 100 years, there's very little rainfall in a desert. And so that would be the climate. And it's very important to understand the difference between those two. So I want to talk a little bit about why climate is so important in my job. And so you should see on the screen, I work for North Carolina Sea Grant, and I'm very, very lucky because my job is really fun, and I get to work with lots of different people like Eric and the Weather Service, and I get to work with a lot of scientists. I get to work with places like aquariums, and I get to go outside and do lots of research with the scientists. And I'm very fortunate to learn about things that are happening in my own backyard. And so when we think about climate, the reason I study climate is because we have found that climate is changing. So the climate over many years, 50 to 100 years, we're finding that it is changing in the places where we live. And so I work with scientists to study how climate is changing over many years. And the places I work in North Carolina are all along our coast. So all the way from the northern part of North Carolina and the Outer Banks, all the way down south to where Wilmington is in the southern part of North Carolina. And I work for, you'll see at the top, that's the program that I work with, the North Carolina Sentinel Site Cooperative. And we look at how climate is changing and how that is impacting where we live. And so for those of you that live in North Carolina, you probably know that we have these islands off our coast called the Outer Banks. And those are islands that are very remote and they're very skinny. So as you can imagine, the ocean is right next to all of those islands. And that's really important because we found that those islands often flood when we have hurricanes or storms. And you can see in that picture that the red areas show that they're very likely to be flooded when we have those types of hurricanes. And as we're going to talk about with sea level rise, those areas are very likely to be flooded and to have lots of water coming up on their shores. So let's talk a little bit about sea level rise. That's what I study in my job every day, and it's very important because it's causing lots of changes where we live. So as climate changes, we found that as temperatures increase, it causes two different things to our water. It causes glaciers to melt up in the North Pole, and also there's something called thermal expansion. And thermal expansion is very simple. It means as water warms up, it takes up more space. And so places, that's my hometown of Beaufort, North Carolina, and you can see as water takes up more space, it's going to get into places like docks and roads, and that's really important where we live because it's going to cause changes in our environment. So this is an aerial view of Beaufort, North Carolina, where I live, and you can see there's lots of houses, there's lots of docks, people live here. We also have lots of natural areas with marshes and plants where lots of animals live. And so you can imagine when we get more water in those areas, it's going to make things very different. And here's another photo of the beautiful marshes that we have in North Carolina. I'm very lucky. I get to go out with researchers and walk around in the mud in the summertime and measure plants and look for animals. And we think about how more water is going to affect those plants and animals and also the people that live near the coasts. So here's one of my favorite pictures. It was really fun one day when our road got flooded. We kayaked down the street. Really fun. But the problem is, so yeah, that's me in the back kayak. The problem is, look at those stores on the other side. The water is almost coming into the doors. And that happens a lot here when we have hurricanes. And it also happens when we have king tides, which are higher water levels. And it's also going to start happening a lot more with sea level rise. So it's really important for our communities and our scientists to think about the changes that are going to happen in our communities. So what can you do? There's lots of things you can do. And one important thing is you can volunteer in your community. This was a project where community members came out and helped plant more marsh grasses in their environment. And that's good to think about how you can be a part of your community and help when we have these big changes that are going to be happening. And that's all I have for you today. I want to say thank you again for joining us and for learning about weather and climate and why they're so important in the jobs that we do. And Eric, I'll pass it back to you. Eric, I can't hear you.
Thank you. I forgot to unmute my mic.
Okay.
So for everybody with us, we're done. If you need to leave at any point, you're all set with the class. But now kind of is the fun part. Think of any questions you have from any of the presentations you saw today and ask us You can do it two ways. Unraise your hand if you already answered a question, because I'm going to call on you if that hand is still up. You can ask it through the question feature on the webinar, and we'll go one by one through those questions. Before we do that, parents, teachers, students, you can help us out. You're going to get this link in your email afterwards, so don't feel that you have to write it down. But if you like this class, please share it with your neighbors, friends, and family. We've learned that on social media, if the post is shared a lot, we have a lot of people in these classes. If not a lot of people show up. We don't have, money to advertise. So social media and our website is the only way we can advertise. If you scroll down on the page, you just took the class today, the weather basics. We have some upcoming Skywarn classes. That's where we teach weather spotters. Belle's going to help us out with the Coco Roz. That's training on rain gauges and precipitation measurement. If you like more about hurricanes, we have a class on that. And then we have another weather basics class coming up in April. So please share this with your fellow neighbors and students. And the last one I want to mention, and again, you're going to get this in your email, so don't feel that you have to know all this. I'm kind of stalling a little bit to make sure some questions come in. If you go to weather.gov, just like Charlie mentioned, weather.gov/learning, there's a lot of educational things for you to do there on the website itself. It's fantastic. Weather.gov/learning. There's games, there's interaction. You can take classes. It's just amazing what the Weather Service has put together. This has always been there, but they created this site to kind of organize it and put it in all one spot. So the way we're going to do things here going forward, let me make sure. I'm going to see if we have an end one. Okay, so I'm going to put this up as an end slide just so we have something there. If you have any questions, shoot me an email. You will be able to, you'll have my email address here pretty soon when I email you. So Charlie, Mike, Sarah, and Belle, and we see Charlie's cat walk by. My cat's always here, but of course he's not. Mike has a dog. I think I saw Sarah has a cat. So we're at home. So again, I know it's a crazy situation, but let's have some fun with it. That's Lacey, so that's Mike's dog. What's your cat's name there, Charlie?
Very original. The cat's name's Kitty.
Oh, I think Sarah's going to get her pet. So I'm going to open up the questions part and see what we've got, and then we'll just kind of go through them. So let me, there's so many questions again. I'm going to probably group them. And who do you have there, Sarah?
Can you hear me?
I can.
This is Hazel, my cat. She's from Trinidad and Tobago.
Oh, wow.
Wow.
She was born here, but her mom is from Trinidad and Tobago.
Okay.
This is Goose.
Very cool. Look at that. I'm sure everybody watching from
She
home
loves
has
being on camera.
a few pets as well. All right, let's see. So I'm going to ask some questions. Let's see what we've got. We've got so many. I'm going to kind of group them, and we'll give all the hard ones to Mike. Is that okay with everybody?
Wait, whoa.
Just teasing. Okay, so this is a good question. So Sarah, Charlie, Belle, I'll just go around and kind of throw it up for you, and then whoever wants to jump in, we'll try to keep it even so everybody gets a chance. But this one is specifically for Sarah, and this is a really good one. So we have a question from William. William asks, Sarah, how do you make marsh grass or grow it?
Sorry, can you repeat that, Eric?
Yes, so William asked, how do you make marsh grass or how do you grow it? Like how would, if somebody wants to become involved and do that, how would they go ahead and do plant marsh grass?
That's a great question.
Oh, sorry.
We've got two. I can hear myself. Okay. So there are, you can buy marsh grass from your local, what are the stores called?
Nurseries.
What? Nurseries, right. So you can buy marsh grass at nurseries, but I think the best way to do it is to partner with one of your local organizations. So for example, here where I live, we have the North Carolina National Estuarine Research Reserve, and it's an organization that does outreach and education and brings school groups out to our marsh habitats and islands. And so they do days where they do community plantings. So I think the best way to, if you want to help plant marsh grass, is to look for organizations on the coast that do those kind of things and get involved in one of their community days.
All right, great. That's great, Sarah. Thank you. So William, hopefully that answered your question. We have another question here. And again, Mike, Charlie, or Bell can chime in on this one. You'll be able to get it. When we send out the balloon at 7 and 7, what's the balloon actually made out of?
Ooh,
You guys
that's a good question.
It's latex.
I can
Right,
take
Bell?
this.
Because I always
latex
ask
one.
if
Yeah.
people have.
So it is. Yeah, the balloon is made of a special latex of some sort. Anytime that we have folks visiting our office, we always ask kids, hey, let's make sure you don't have a latex allergy, because if you touch it, then you get allergic. And the nice thing about this special latex is that once it gets really high up in the atmosphere, and eventually it pops, what it'll do is it'll fragment, and it'll pop out and turn into little tiny pieces. So that when they come back and down to Earth, they have a very small environmental impact to our ecosystem. That's a great question. Thank you.
I appreciate the feedback we're getting. I should mention, I know a few folks have dropped off, but if you like these classes, send us an email. Again, the best thing you can do is share it with others so we get these classes filled up. Rebecca, Broad Creek Middle, I appreciate the feedback. She mentioned that, 7th grade, they do weather as well. So for those that are on, we aim for 5th grade standards, but that's applicable in 7th grade to down to 1st or 2nd. So we try to keep it for everybody. Here's just kind of a general question, either Charlie or Bell, again, in just real simple terms, how do we forecast the weather? So maybe A to Z, real simple, unless you want me to do it. Just how do we forecast the weather? Just, hey, we kind of talked about today. We use instruments to know what's going on, the models, just something quick.
I guess, go ahead, Bill.
All right. That's basically how I call it. We start with basics. It's kind of what Eric ended up already mentioning, is that we take the weather instruments and we take the observations from those weather instruments. That data that comes from those weather instruments gets inputted into our database. It gets up to the weather models as well. So looking at the current conditions from the weather instruments, and then looking at the weather data, that gives us kind of like a basis of where to start, and then see which model is actually doing a really good job, and then we'll lean towards that model to make our forecast. So that's where we can actually, do the temperature forecast, wind forecast, and of course, I call it our cloud conditions. So that's kind of just more of a basic way of putting it.
That's great. Good job, Belle. So we're just going to do just a couple more questions because I know we are we're kind of bumped up against time, and I know that we've got to get a little work done here. But I want to try the microphone. So Jacob Boyd, I know you asked a question through the program, but you've got your hand raised. So I'm going to see if you want to ask it as well. So let's see if you're there. Jacob, are you there with us?
Can you hear us?
I can.
Hey, this is Jacob Boyd, but Harper Gray Boyd, my daughter, is the one who wants to ask the question.
Okay, and what was the name again? You said Harper?
Harper, yes, sir.
Okay, all right, Harper. What do you have for us?
Do fish come on land when it floods?
All right, so Harper asked, do fish come on land when it floods? And unfortunately, they can. If anybody wants to chime in more, but the thing that I'm thinking of is the picture of I-40 during Florence. We had some fish on Interstate 40, which is north of Wilmington. So they don't naturally want to come on land, but sometimes, unfortunately, they come where the water goes. And then as the water recedes, sometimes, unfortunately, they can still remain on land. So that's how I was going to answer it. If anybody else wants to chime in differently, but I think that pretty much covers it.
Pretty much. Also, don't forget the ocean side as well. When
Yes.
we get enough storm surge, fish do sometimes come on land as well from the coastal side.
All right, we've got a question from Landon. Landon West asked, why are there not category 6 to 100 hurricanes? So I would say that, the category is only related to wind, so we just go up to 5. And we don't have any stronger categories because it's only related to wind, and there's actually a lot more impacts with the hurricane than just the wind itself. You have flooding, you have rip currents, you can have storm surge. So if we were going to increase the number that much, people might think that the category is more important than it really is. And we're trying to actually get people to not focus on the category only, but all the different impacts. And he also asked about the difference between all the world's type of hurricanes. The only difference is names. And I think, Mike, I think you covered that section. Even though it's called a Willy down toward Australia, it's still a hurricane. Meteorologically speaking, it does the same thing. It has wind and rain and storm surge. It's just called something different, even though it is actually not different. Here's one for you, Sarah.
Eric, if I can add on to that.
Yes, please.
Let's talk to the hurricane expert.
There isn't a category 6 or there isn't a category 100 hurricane based off of physics. When you get older, you'll take physics and you'll understand. But eventually, hurricanes can only get so strong because once they get to a certain strength, they actually start to eat themselves and they tear themselves apart. So that's why there's sort of a theoretical maximum wind speed that a hurricane can get to. And then the only other difference with hurricanes based off of location is in the southern hemisphere, they spin the opposite direction. Just like I'm sure if you've heard that in the southern hemisphere, toilets spin in the opposite direction when you flush them. Hurricanes spin the opposite direction in the southern hemisphere for the same reason that the toilets spin, and that's called the Coriolis force, which you'll get into in your later science classes. Great question.
Yeah, that's a great question.
Thank you, Charlie. We've got one for you, Sarah. Before we turn it over, it's another marsh grass question, so you can prepare for that. Included in your email will be a link to our YouTube page. We mentioned that there's a lot of videos on here. In addition to this presentation, which we've recorded, our spotter training is on there. But if you click on videos and you scroll down, we talked about weather balloons a lot, and we've actually got a couple videos on weather balloon. We've got a short one that's just about 9 minutes long. We've got one that's 50 minutes long. So we've got, from A to Z on balloon launches, and we even have a time lapse on here somewhere as well. So I should probably organize that actually now I think about it into some playlists, but that's all on our YouTube page. All right, so Sarah, so William asked earlier, like, where can you get the marsh grass? Samantha Guthrie asked, where would you plant the marsh grass?
Thanks. That's another really good question. So there are many places you can plant marsh grass. So you saw the photo of me out on basically a nature preserve, so out on an island planting marsh grass. And that's an area where we get a lot of boat traffic that goes by. So we get a lot of waves that come onto the shore, and they cause erosion. So they carry away a lot of that sand and sediment that's right at the shore. But if you have plants planted in that area, then their roots can help hold the sand and the soil in place and help slow down erosion. So really anywhere where you're going to have erosion is a really great place to plant marsh grasses in a coastal environment. Another good place is a lot of people that own homes right on the water. They can go ahead and they can plant marsh grasses right on their property. It's actually called a living shoreline. And if you guys are interested in living shorelines, feel free to email me. I'm happy to give you more information, or you can Google them and learn about living shorelines. So you can use marsh plants and oyster reefs right on your shoreline where you live to help protect against things like erosion and waves from hurricanes or storm surge. So there's a lot of scientists that are researching living shorelines and the best way to plant marsh grass and marsh plants to help protect our shorelines and our homes. So thanks, that was a really great question.
All right, very good. We're going to do 2 more questions and we're going to wrap things up. If we didn't get to your question or you think of something else, you can always email me. I'll put Charlie in the hot seat for the very last one, so don't leave, Charlie. They're going to ask about hurricanes spinning in the opposite direction in the southern hemisphere. So since that's a tricky one, think about it. They're asking why that happens, so I don't want to totally put you on the spot. That'll be our last question, but the second to last one, I see Brittany Kearns has had her hand raised for a while. So let's see if Brittany is still there. Brittany, are you with us?
Yes.
All right, Brittany, what is your question?
How can you tell if it's a hot front or a cold front?
Very, very good. These are outstanding questions. Teachers, if you're on with your students, they're a sharp bunch. So I can always answer it, but does somebody else, Mike or Bell? So Brittany had asked, how can you tell that it's a warm front or cold front? You want to take a stab at it, or?
Yeah, I can take a stab at it. And so how do we tell a warm front from a cold front? I mean, it goes right back to what Eric was talking about for those weather observations right on the ground, right? That temperature, the barometer, all that information from those weather stations. And the nice thing about those weather stations is that they report to us every hour, sometimes every 15 minutes. And we know when there's a cold front or a warm front based on where the cold air is and where it's going towards, and then also where the warm air is and where it's going towards. So sometimes we'll see somewhere in New Bern saying it's going to be 76 degrees, and down in Jacksonville it's 46 degrees. And if we see that the warm air starts moving down towards Jacksonville, and all of a sudden they're at 68 degrees, we know that the warm front is moving south. So we will follow those observations. In addition to that, too, a lot of times when a front moves through, the winds will shift. So basic stuff. In the north, it's a little bit colder, and in the south, it's a little bit warmer. So when the wind is from the south or the southwest, that's typically warm air. But if it shifts suddenly to the north or northwest, northeast, we know that a front moved through. So again, it goes all the way back to just simple observations that we see from thousands of weather stations across our area.
All right, Mike, thank you very much. So this will be the last one. So Charlie, Will Vaden asked, why did hurricanes spin in the opposite direction in the southern hemisphere?
Okay, I'm off. You can hear me, right?
We can.
Well, great question. So the simplest answer is the place that you live is on a giant floating rock that's spinning through space. So because the Earth is spinning, it's going to create what's called the Coriolis force. And that Coriolis force is exactly 0 at the equator. But as you move north, that Coriolis force changes and it's going to become greater. In the northern hemisphere, it's a certain sign, and when I say sign, I mean positive or negative. So within all these math equations and within all the physics, if you're in the northern hemisphere, because of the Coriolis force and how it affects the different pressure gradients, and which affects the wind, which in turn is affected by the friction that the wind feels from the surface, it turns the wind a certain direction. So in the northern hemisphere, because of the Coriolis force being that constant sign in the northern hemisphere, you get those counterclockwise rotating hurricanes. Whereas in the southern hemisphere, where you're dealing with willy willies in Australia, the Coriolis force is a different sign because it's on the different side of the equator, and so they get the different effect from the Coriolis force, which turns the wind a different direction as it does in the northern hemisphere. So that's why in the southern hemisphere they get the clockwise rotating hurricanes or clockwise rotating willy willies, and northern hemisphere we get the counterclockwise rotating hurricanes.
Charlie, that was really good. We picked on Charlie because he's the newest person here, and not because he's the newest, but he's the closest to college. So I figured he had the best chance because I think the oldest one here. I don't know, Belle, we're close. We won't say our ages, but we're the farthest away. So we certainly can't remember yesterday. So we picked on Charlie because he's the closest to college. All right, so that'll be it. Sarah, Mike, Belle, Charlie, really appreciate you joining us. I think it went well. Kids, students, parents, if everything goes well with the recording, we'll post it on YouTube. It may take a day. Sometimes it takes a while to edit out the end so it doesn't get too long. But once we get it up on YouTube, I'll send you an email with a certificate and all those links that we promised. So hang tight for that. Appreciate you joining us, and sign up for one of those future classes. Again, we've got a lot coming up that go more in depth into the month of April. Hurricanes, rain gauges, flood sky warn, all kinds of stuff. And there's Lacey. Lacey was so interested in the class that she fell asleep. All right, everybody, have a great day.